Bobcats. In this video, we're going to look at how we draw Lewis dot structures for polyatomic ions. The two main differences between neutral compounds and polyatomic ions when it comes to their Lewis dot structures are that we're going to have to adjust the valence electron count to account for that charge. And then we're going to also introduce square brackets outside of our Lewis dot structure, and then we're going to put the charge outside of those square brackets to complete the Lewis dot structure for a polyatomic ion. When we're taking the valence electron count, keep in mind that an electron has a negative charge. So if our polyatomic ion has a negative charge associated with that, that means it has extra electrons. So for instance, if we have the phosphate ion with its -3 charge, once we've added up the electrons that all of the atoms contribute, we have to add another 3 to that total electron count. But if something has a positive charge, that means it's lost an electron. You all know that bad joke, right? About sodium and chlorine are walking down the street and sodium says to chlorine, "Ooh, I think I lost an electron." And chlorine says, "Are you sure?" And sodium says, "Yes, I'm positive." Haha, right? So if you lose an electron, you end up with a positive charge. So for something like ammonium, which is a +1, we're going to have to take away 1 electron from that valence electron count to represent that lost electron. And then, yes, we are going to need to use square brackets outside of our Lewis dot structure for a polyatomic ion. So let's start with an example of a polyatomic ion that's called hydronium, and its formula is H3O + 1. We have 3 hydrogens, which each bring 1 valence electron. There is 1 oxygen, which will bring 6 valence electrons. And then there is this +1 charge, which means it's lost an electron. So we'll say -1. Because it's that -1 right there is done because of the charge. It has lost 1 electron if it has a +1 charge. So we have 3 + 6 is 9, -1 is 8. So we have 8 valence electrons to work with in this structure. Hydrogen is never our central atom, so that means oxygen must be. We will put the 3 hydrogens arranged around it in any 3 of the 4 positions that are available. Then we go to put those 8 valence electrons into the structure. We will start by putting bonding pairs to satisfy the duet on our outside hydrogen atoms. That uses 6 of our 8 electrons, so those 2 leftovers have to go on that central oxygen. Oxygen has an octet. Each of the hydrogens have a duet. And so the last thing we have to do, because this is a polyatomic ion, is draw square brackets around our structure and then put a +1 charge outside of those square brackets. The cyanide ion has 1 carbon atom, which will bring 4 valence electrons, and it has 1 nitrogen atom, which will bring 5 valence electrons. And then it also has this -1 charge, which means it has 1 extra electron, so we'll have to add 1 into this count, which comes from that -1 charge. This gives us a grand total of 10 electrons to work with. Again, with 2 atoms, we really just put them side by side, and then we can start putting an octet on 1 and rearranging as needed. So let's start by putting the octet on the carbon. That uses 8 of our 10 electrons. And so if we put the remaining 2 over here on nitrogen, that's using up all 10 electrons we have to work with, but poor nitrogen is really short of an octet. So we need to start sharing some of these lone pairs to increase the number of electrons that are associated with nitrogen without taking any away from the carbon, because we still get to count the shared pairs towards carbon's octet. So now with 3 shared pairs, we're going to have carbon with a triple bond to nitrogen, and then there'll be a lone pair still on each one of these atoms. To complete it, since this is a charged species, we'll put it in square brackets and put that charge outside of the brackets. So for a quick review, we have to adjust the valence electron count when we're working with polyatomic ions. For negative ions, we give it extra electrons. For positive ions, since they lost electrons, we take electrons away. And always remember to use the square brackets around the polyatomic ion Lewis structures, along with a notation of what the charge is.